In this video, we're going to be drawing the, let me say, we are going to be using the name to draw a structural formula for different compounds. It's kind of different from the one I made from the IUPAC naming of the first and the second video I actually made. But in this case, we are going to be using name to draw a structure, right? We are going to be moving from name to structure. The other one is actually from structure to name. You understand? So now, the first case that we have actually is actually 1-pentene. So we are asked to draw the structural formula of 1-pentene, right? 1-pentene. And then one thing I want you guys to understand is that you first bring out the carbon atom, number of carbon atom, right? Since this is pent, pent simply means 5, right? Then you're going to have 5 carbon atom. 1, 2, 3, 4, 5. This is pent. Now, in 1-pentene simply means the in is actually a double bond. Don't forget, if it is in, it is single bond. If it is in, it is what? Double bond. And if it is I, that is triple bond, right? So this is in, and then it is on position number 1. That's the reason we have 1-pentene or pent 1 in. So on carbon number 1, we're going to have double bond here. So this is basically 1-pentene. So you're going to fill the rest with hydrogen. So this is going to be hydrogen, and don't forget, carbon can form 4 bonds at the time. We're going to have 1, 2, 3. That's why you need another hydrogen here, right? So hydrogen is going to be here. Then fill the rest hydrogen. Hydrogen is going to be here. Hydrogen is going to be here. Hydrogen is here. All right. Hydrogen is going to be here. We're going to have hydrogen and also what? Hydrogen. So this is what? 1-pentene. Now the skeletal formula is going to be, in this case, pent is basically 5, right? You're going to have 1, that's 2, 3, 4, 5. Then at this point, we just put a double bond here, right? This is 1, 2, 3, 4, 5. 5 carbon atom, and this is what? Pent. That's 1-pentene. This carbon number 1-pentene. This is skeletal formula and this is structural formula. So this is 1-pentene and 1-pentene. So now let's go ahead and draw another skeletal formula. Now take a look at this name. We are having 2-ethyl 1-pentanol. 2-ethyl 1-pentanol. Now one thing I want you guys to understand is that whenever you have pentan, pentan simply means all the carbon atom they are having single bond all through. Pentan. If it is pentene, you're going to have double bond. If it is pentine, you're going to have triple bond. But in this case, everything is actually going to have single bond all through. That is, the carbon are going to be connected with each other with just a single bond. And since it is pent simply represents 5 carbon atom, Abby. This is basically 5 carbon atoms. So we're going to have carbon 1, 2, 3, 4, and 5. Right? That's what we have. Then, oh, this is basically one alcohol group, right? We're going to have it at this point, OH. Then 2-ethyl. We're going to have ethyl group at carbon number 2. This carbon number 1 and this carbon number 2. We're going to have C2H5 here, right? So this is going to be hydrogen, right? This is going to be hydrogen. 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 This is going to be hydrogen, right? You fill the rest with hydrogen. This is going to be hydrogen. And then at this point, we're going to have hydrogen here and then hydrogen here. So this is going to be 2-ethyl 1-pentanol, right? Because this carbon number 1 and this carbon number 2. On carbon number 2, you are going to have what? Ethyl group. And this is the ethyl. 2-ethyl 1-pentanol. Then the skeletal formula is going to be in this way. We're going to have 1, 2, 3, 4, 5, right? Now, on position number 1, we're going to have alcohol functional group, and I'm going to put it here. We're going to have OH here, right? This OH. Then 1, 2. On position number 2, you're going to have ethyl group. So you're going to have something like this. This ethyl group. So this is basically 2-ethyl 1-pentanol. That's basically the name. Now let's go ahead and write out another name. Now look at this one. We have 2-methyl 3-heptene, right? 3-heptene. First thing is that hept, that is here, indicates the number of carbon atom, and then hept is basically 7 carbon atom, right? This 7 carbon atom. Then that simply means I'm going to have 7 carbon, 2, 3, 4, 5, 6, 7, right? And these 3 that you are seeing here basically represent the position of what? Of this ion, right? This is basically 2-methyl hep 3 or you simply say 2-methyl 3-heptene, right? So on carbon number 3, we are going to have triple bond. This carbon number 1, carbon number 2, and carbon number 3. So here we are going to have triple bond, right? This is going to be our triple bond. Then at the same time, on carbon number 2, we're going to have methyl group. So on carbon number 2, we're going to add a methyl group here, CA3. Then we're going to fill the rest with hydrogen. So don't forget, carbon can form 4 bonds at a time, right? So this guy has complete bond, right? And this guy has your complete bond. Then put hydrogen here. So on this case, in this case, we're going to have 1, 2, 3, 4. It's already complete. 1, 2, 3, 4 is already complete. Then we just go ahead and put the hydrogen here, right? Hydrogen here, hydrogen here. So this is basically 2-methyl 3-eth-ine, right? Now, if you want to draw the skeletal form, you're going to have 1, 2, 3, 4, 5, 6, 7, right? If you have something like this, you already know on carbon number 3 we are going to have eth-ine. This 1, 2, 3. Then you're going to put a double bond here, a triple bond here, right? This carbon 1, carbon 2, carbon 3, right? So on carbon 3 we are going to have ine here, this triple bond. Then on carbon 2 we are going to have a methyl group. Carbon 1 and carbon 2 we're going to have a methyl group here. So this is basically 2-methyl 3-eth-ine. That's basically what we have. Now let's go ahead and write another one out. Now, if you look at this, we are having 3-ethyl 4,5-dimethyl pentane, right? So first thing, you have to bring out the number of carbon atom, and the number of carbon atom here is what is pent, right? Since it is pentane, that shows that all the carbon atom are going to have single bond all through. So I'm going to have 5 carbon atom here. 1, 2, 3, 4, 5. Then if you are drawing skeletal form, you're going to have 1, 2, that's 3, Abby, 4 and 5. 1, 2, 3, 4, 5, right? Then 3-ethyl. On position number 3, we are going to have ethyl group. This is position 1, 2, and 3. On this guy here, we're going to have C2H5, which is ethyl, right? So that basically means on 4 and 5 as well, we're going to have 2-methyl group. So on this side, I'm going to have CA3, and on this side as well, I'm going to have CA3. So this is basically 3, 4, 5, right? So on 4 and 5, we're going to have methyl group. So here I'm going to fill the rest up with hydrogen, right? Hydrogen is going to be here, hydrogen is going to be here, hydrogen is going to be here. Then I'm going to have hydrogen here, hydrogen is going to be here, hydrogen is here, and hydrogen is here. Then on this guy here, on skeletal structure, carbon 1, carbon 2, and carbon 3, I'm going to have an ethyl group here, which is what we are saying here, this ethyl group. And carbon 4 and 5, I'm going to have methyl. We're going to have a methyl here, and carbon 5, we're going to have another methyl group here. Sorry, let me basically represent as this, because if you go ahead and count like that, it has already changed the form, right? So let's basically see what we're going to have if we represent as this. So I'm coming with 1, 2, 3, 4, 5, right? So if you go ahead and consider this side, this one that you're seeing here, right? 1, 2, 3, 4. Let me just draw it like this: 1, 2, 3, 4, 5. So let's say, let me just drop this side here, because if I put entire group here, it's going to change it, right? So now let's see what you're going to have: 1, 2, 3, 4, 5, right? On position 5, right? On position 5, I'm having methyl group. So we have put methyl group here, and on position 3, I'm having ethyl group here. So that's going to be 1, 2, right? So 1, 2, 3, 4, 5, right? Then it's not going to make sense like this as well. Let me just go ahead and use the trace form: 1, 2, 3, 4, 5. Then 1, 2, 3, we're going to have methyl group, right? And then we are going to have methyl group here and methyl group here, right? So let's just go ahead and hold it that way, right? So that's just it. So now let's go ahead and write another one out. Now look at this name. We have 3,3, 6,6 tetraethyl 4-octane. Now octane, oct simply means 8 carbon atom, right? Ine simply represents triple bond. So this triple bond, right, and this 8 carbon atom. So let's draw 8 carbon atom. We're going to have 1, 2, 3, 4, 5, 6, 7, 8, right? Then on position 4, 1, 2, 3, 4. This position 4, we're going to have triple bond, right? On position 4, 1, 2, 3, 4, right? So that's 4-octane. Then we are having tetraethyl. Tetraethyl simply means we are going to have 4 ethyl group. On what position? Position 3. 2 on position 3. 1, 2, 3. So at this point, we're going to have C2H5, right? And at this point, we're going to have C2H5. That's on position 3. right? Then and on position 6, 1, 2, 3, 4, 5, and this 6, right? We're going to have another ethyl group, C2H5, and then another C2H5. That's what we're going to have. Then I'm going to fill the rest with what? Hydrogen. So we're going to have hydrogen here, hydrogen here, hydrogen here, hydrogen here. Hydrogen is going to be here, right? Then at the same time, we're going to have hydrogen here, hydrogen here, then hydrogen is here, put hydrogen here, and hydrogen here. So this is basically 3,3, 6,6 tetraethyl 4 octane. Right, now let's see if the skeletal formula is going to be very, very easy to draw. Right, since we are having oct 8, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, right? Then on position 4, 1, 2, 3, 4, we have triple bond. So I'm going to put a bond here, and I said I'm going to put a bond here, which represents what? A triple bond. Then 1, 2, 3, 4. Position 4, I'm having triple bond. Then on position 3, this is 3, I'm having 2 ethyne, C2H5. So this is what I'm going to have 1, 2 here, and I said I can go ahead and put 1, 2 here. So this is the 2 ethyne, and on position 6, 1, 2, 3, 4, 5, 6. 6 as well. I'm going to have ethyl as well. I'm going to have one here and one here, and the other one here. So this is basically how the structural formula is going to look like, because this 1, 2, 3, 4, 5, 6, 7, 8, right? Then on position 6 we're having what? Ethyl, and on position 6 we're having what? Ethyl. On position 3 as well we're having ethyl, and also what? Another ethyl. So that's going to be the what? The skeletal structure. Now let's go ahead and write another one out. Now look at this theme. We're having 5-chloro-4-methyl, right? 4-methyl, 3-heptanone. That's what we have. Hepta simply means 7, right? So let's go ahead and write 7 carbon atom. 1, 2, 3, 4, 5, 6, and 7. Tan, it simply means all the carbon atom is going to be connected with just a single bond. None simply represents a ketone. This is a ketone functional group. Then on position number 3, that's why this functional group is going to be on position number 3. Then let's come back. 1, 2, 3. So we're going to have double bond O here, which is a carbonyl compound. Right, that represents 3-heptanone. This is basically 3-heptanone. 1, 2, 3, 3-heptanone. Then on position 4, we're going to have methyl group. Right, we're going to have CH3 here. And then on position 5, we're going to have a chlorine group. We're going to have Cl here. So this is basically 5-chloro-4-methyl 3-heptanone. Now let's go ahead and fill the rest with hydrogen. Hydrogen is going to be here. Hydrogen is going to be here, right? We're going to have hydrogen here. Hydrogen will be here. Hydrogen will be here. Hydrogen is going to be here. Hydrogen is going to be here. Hydrogen is here. Hydrogen is here. Hydrogen will be here, right? And at the same time, hydrogen is going to be here, and at the same time here. So this is basically 5-chloro-4-methyl 3-heptanone. That's what we have. Now let's go ahead and draw the skeletal structure, and that's going to be something like this. We're going to have heptane. That's 1, 2, 3, 4, 5, 6, 7. So this is going to be 1, 2, 3, 1, 2, 3. If I start counting like this, right, I'm going to have double bond O here, right? This is going to be the position of the arcanone. Then 1, 2, 3. On position number 4, I'm going to have a methyl group, which is what I'm going to have here. And then on position 5, I'm going to have a chlorine group, which is what I'm going to put here. So that's what we are going to have. So this is basically 5-chloro-4-methyl 3-heptanone. Right? So now let's go ahead and write another one out. Look at this question, right? You can go ahead and try it out, and then if you get the same structure as the one I'm going to get, you can just drop yes in the comment box below. Right? So now let's go ahead and attempt this guy here. So what we have here is actually what? Pentanol, right? 2-pentanol. Now let's go ahead and draw 2-pentanol. Pen simply means 5 carbon atom. 1, 2, 3, 4, 5, right? Then 2-pentanol on carbon 1 and 2, we are going to have OH on carbon number 2, right? We are having 3-ethyl. On carbon number 3, we are going to have ethyl group, which is going to be C2H5, right? Then on carbon number 2, we are going to have another ethyl group, right? As you can see, on carbon number 2, we are going to have another ethyl group. That's going to be C2H5 again. Sorry, we're going to have methyl rather, not ethyl, methyl rather. That's dimethyl. So we're going to have CH3 here, right? And then position 3 as well, we're going to have methyl group, which is CA3. Then I think we're going to fill the rest with hydrogen, right? That's what we're going to have left because we don't have any more substituent again. So this is basically 3 ethyl, 1, 2, 3, 3 ethyl, right? Then 2, 3 dimethyl. On position 2, we're having methyl. On position 2, 3, we are having what? Another methyl group. That's dimethyl, right? Dimethyl. Then 2 pentanol. That's 2 pentanol. So that's basically the name. Now let's go ahead and try out the skeletal structure. That's going to be pent, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then on position 2, 1, 2, we're going to have OH. This is going to be OH. Then on position 2 as well, we're going to have methyl group. We're going to have methyl group. This is what I'm going to have. Like this is my methyl group. Then at the same time, on position 3, we are going to have methyl group. I'm going to represent as this. And at the same time, we're going to have ethyl group. I'm going to represent as this. This is the ethyl group. So this is basically 3 ethyl, 2, 3 dimethyl, 2 pentanol. So if you have the same answer as my own, you can actually drop the answer. You can drop your, now let me say, you can drop yes in the comment box below. So that's going to be the end of this video. If you find this helpful or you enjoy it, please kindly like, share, and subscribe.